All right, 7.4, we've been looking at percents. And in particular, we had left off on looking at mental math. That's where we had just finished up right here. And then we're going to take a look at some application of percent for for one question. Then we're going to move on into a big application of percent after that. So here's our first question for today, example 7. Why is it possible to have an increase of 150% in price, but not a decrease of 150% in price? What do you think, Abriana?
Probably because if it was like decrease 150, you'd be like negative.
Yeah.
Amount.
Yeah. So if we were to decrease 150%, we'd be at a negative amount. We could decrease in the 100%. That takes us all the way back to 0, right? So technically, in terms of a number, like a value of something can decrease completely 100%. So if you think about like the stock market, when the stock market crashed, if there were companies that completely went under completely, then whatever your stock is, you lost 100% of it. That would be a decrease of 100% in price. But you can't go negative. Right? It doesn't make sense to talk about a decrease into a negative sphere. So that's why the negatives won't work. Why can we have an increase? Actually, let me say decrease first. How could we increase 150% in price? What does that mean? What does it look like for something to increase 150% in price? Double and then some. So that's a really good way to describe it, actually. So if it's an increase in price, it's going up. There's no cap on how high something can go, as a general statement, right? So we're experiencing inflation right now with percentages, not 150% on most things, but eggs have gone up a lot, over 100% in the last 2 years. Eggs are crazy high again. They were high about a year ago, and then they came back down, and now they're high again as well. So we can definitely increase more than, to whatever amount we want. So if we were increasing 100%, that would double our price. The 50 in the 150 then would be the and more sum, right? It would be another half again as much as what we had before. So the real issue is that decreasing, we've kind of cut a lower bound, right? We can't enter into the negative number realm. That doesn't work for what we're talking about. But we can increase by any percent because we don't have an upper bound, really. And I'm going to write down that phrase. This would be double and then some more. All right, so if the price doubles and then you add a little bit more to it, you're in the over 100% addition, and that actually is possible to do. All right, you ready to take a look at some interest stuff? This is an application of percent, is a big application that we're going to look at. So an interest application is with percent. Interest is the amount of money that you pay or that you earn to borrow or to lend money. Principal is the original amount that's used to determine the interest. So typically speaking, it's the amount that you borrowed if you're doing a loan, or it's the amount you invested if you're putting it into something that you're investing it in. The interest rate is the percent that's used to determine the interest. And the only interest that we're going to be taking a look at in this section is called simple interest. We do compound interest in lots of other places, but for the purposes of the children you guys would be teaching, that's above your level of expectation, right? Like compound interest shows up in high school. So this is why we're doing simple interest only, all right? So simple interest has one of two formulas. It's either A equal P plus PRT, or A equal P times 1 plus RT. And I hope that you can see that these are really very similar formulas. If you distributed the P, when the one that has the parentheses, it'd turn into the other formula. Okay, they're a little bit different perspective of things, but they're just the same thing written differently. Interest is I equal PRT. Okay, that's what interest is. Now, let me just identify what each of these things are in terms of their letters. So the P here is principal. It's the principal mentioned above. The R is the rate, the interest rate, and it needs to be done as a decimal, not as a percent. So we need it in decimal form. And T is always time, and it needs to be time in years. Okay? T is always time in years. And it's the same thing in the formula down here for the PRT down here. All of them are the same. I is interest, right? For the amount that you have. Maybe I should mention what A is. A is the amount after T years. So I is the additional money the bank put onto the loan or onto the account that you have. But the A is how much you actually have in the account after all of that's been like taken care of, added to it or taken away from it. Okay, ready to try one? Okay, we've got a company and it's expanding its line to include some more products. In order to do this, it borrows $320,000 at 13.5% annual simple interest for a period of 18 months. The question it asks is, how much interest will the company be charged? Okay, so taking a look at, there's 3 different kinds of formulas here. Which one will find what we want the most directly? So we have, let me highlight them. Here's one, and here's one. Which of those 3 formulas, any of them can be used to find what I'm looking for. I could use any of them actually. But which one will find what I'm looking for the most directly?
Interest one?
The interest one. It specifically asks me for interest in this problem. It doesn't ask me how much they're going to have to pay back at the end of the term of the loan. That would be the A. So if I want to find the answer most directly, I want to use that bottom formula. So we're going to find interest. Sorry, it's P first. Like this. So interest is what I don't know. P for the principal. So the principal is how much we loan or borrow. What is that in this problem? It's not a trick question, I promise. Yeah, the $320,000, right? That's how much they're borrowing. So that's my principal. What is the interest rate? Yeah, it's the 13.5%, right? But when I put this into the formula, it needs to be inserted as a decimal. And yes, I know 13.5 has a decimal in it, but it's still a percentage. It's just a percentage that has a decimal point in it. I need to change that percentage into its equivalent decimal value. And we talked about that last time. That has to do with moving the decimal place over, right? So what will this be as a decimal number? 0.135. So that's the R in my formula. And what is my time?
1.5 years.
So it's 18 months, but we can't do 18 months. Who told me it was 1.5 years? Aaliyah, why did you get 1.5 years, or how did you get 1.5 years?
18 divided by 12.
Yeah, 18 divided by 12 is 1.5. This is a year and a half. You probably can think about it in terms of a calendar as well if you'd like. This is a year and a half, so we want to make sure we're putting it in terms of the number of years, not the number of months. So you're going to need a calculator. Go ahead and grab it and multiply these 3 numbers out. What do you get that they're paying in interest? $64,800 in interest. Okay, let's go to another one. Example number 9 is a very interesting question that's perhaps a bit counterintuitive. So let's go through this. So because of a recession, the value of a new house depreciated 10% each year for 3 years. And then the economy begins to recover and the house increases in price 10% per year. Okay? So it sounds like it goes down 10%, 10%, 10%, goes up 10%, 10%, 10%. And you might think, well, it's about back where it was before. Nod your head if that sounds like a general leak. Like that's kind of what it looks like, right? So that's not how percentages work. So I want to show you how these work and how to think about this to verify what's really happening. Now notice it does not tell you how much the house was worth, correct? And it really doesn't matter what the house was worth, so we can make something up. So we're going to make up something that's nice and easy to work with, maybe not super realistic in terms of a value for a house anymore, but we're going to use $100,000. Are you good with that? Okay, so we're going to call the house $100,000. So let me show you how we can think about this. So this is our beginning value. Our beginning value is that we have the house and it's $100,000. So after year 1, it tells us that it's going to go down 10% in price. So if it goes down 10% in price, how much of its value is it retaining? 90%. Right, if you lose 10% of its value, you're keeping 90% of its value. Does that make sense? Okay, so what I'd like to do is I'd like to take that 100,000 and multiply it by 90%, or you can just put 0.9 if you'd like. This is how much the value of the house will be after it's gone down 10% in value. This one's really nice. It's just $90,000. Okay, so it lost $10,000 of value, correct? But now, when it loses value the next year, it doesn't lose $10,000. It loses 10% of the $90,000. Okay, so year 2, we now have a house that's worth $90,000, and we're losing 10%, which means we're keeping 90%. How much is the house worth after year 2? $81,000. I should put a dollar sign. Okay. Lost $10,000 in value the first year, lost $9,000 the second year. Make sense? Fabulous. All right, let's go on to year 3. Okay, now the house is not worth $100,000, it's not worth $90,000, it's worth $81,000. And I'm decreasing again in price by 10%, so I'm keeping 90%. How much is the house worth after year 3? Yep. Okay, so it didn't go down to 70,000, right? It did not lose 10,000 per year. It only went down to 72,900. And then the economy starts to recover. So when the economy starts to recover in year 4, instead of it going down in price in year 4, it goes up in price. So now I have a $72,900 home, but instead of multiplying it by 90%, what do you think I might be multiplying it by? 110%. Okay, because it's going to go up 10% in value off of the original 100% value. 110% would be the decimal like this, 1.10. So then what is 110% or 1.1 times my 72,900? I think this is where we get a funny number. Do you have some decimals on this one? Yeah, I think so. Anybody have a value?
Got 80,190.
Is it even 190 right now? Yes? Okay, it must be the next one. All right, year 5, same thing, right? On year 5, it's now starting with 80,190, and it's going up 10%, so it's times 110%, or 1.10. And what does this one give us?
88,209.
Okay. 88,209. And we're on to year 6. It's the end of our discussion. 88,209 up 110%. Where does that leave us?
97,029.9.
Okay, there's my decimal showing up, right? Like 90? Okay. Okay, so going back to the question, did the value increase or decrease did the house increase or decrease in value? It decreased. We're comparing where we started, which we could have started anywhere. We chose 100,000 to where we ended, and we ended at 97,000. So this decreased in value. And the reason is because what I multiply each time is changing. So the amount that I'm losing at the beginning is based on bigger values, right? And then I'm adding back those 10%, but I'm basing them on smaller values. So when they get added back in, they don't make up for the loss completely. Now the second question asks us, by what percent did it increase or decrease over the 6-year period? So this is where we did our proportion kind of problems. Okay? We said that the house started at 100% value at $100,000. Right? What value did it end at? 97,000. 2990 or something like that, right? Cool. And then we're going to find that value x. So if we cross multiply, we have 100,000x, and then we have 97,02990, and divide by 100,000. What is the x? What is the percent that we get? Like this, right? 97.029%. Now, that doesn't exactly answer the question that was asked. What was the question that was asked? What did it say? Yeah, what percent did it increase or decrease? It started at 100% and now it's at 97%. That's less. But how can we use those values to figure out the amount that it decreased? Subtract them, right? So if we took our 100,000 or 100% and we subtract this 97.029%, that will be the amount that it has decreased over that 6-year period. And this should be it's about 97%. Okay, so it decreased approximately 3% in value over that 6-year time frame. Very unfortunate if you were looking for the house to be an investment, but it could have been worse. We could have stopped 3 years in, right? Could have been worse. All right, I want to show you one other example. So during COVID, I collected data for over a year of all of the case numbers in Oklahoma. And I did it for the purpose of being able to make a problem about it in some kind of a statistics class or in one of my contemporary math classes or something like that. So this is actually coming from real data. So as of August 1st, 2020, the total number of positive cases of COVID-19 in the state of Oklahoma stood at 37,731. The population of the state, the closest date I could get was July 1st. So we're going to just be okay with the fact that these are about a month across, okay? Some people died, some people were born. It's probably a wash. Are we agreed on that? Okay, good. The actual population count at that time is 3,956,971. Okay, everybody good? There's a number of people who have had or currently had COVID at that point, the total count that they had, and then there's the total number of people in the state. So question number 1 wants to know what percent of the Oklahomans at that date had contracted, right, COVID-19. So we're going to do this again. It's a percentage. So we have our 37,731, the number of people who had contracted it, and we have our 3,956,971 total population. So we have 100% of the bottom, that's all the people, and we're looking for the percent on top that corresponds. So we're going to cross multiply. We have 37,731,00. So that's 3,773,100. And we have 3,956,971X. So we're going to divide by our 3 million number, well, the 3,956 number. What do we get? Let's go with 2 decimal places.
9,500.
Yeah, 9,500s or 0.95%. So this is almost 1%. Okay, so when school started in 2020 in the state of Oklahoma, or the school year would have started approximately, 1% of the population of our state either had or had already had, right, previously had COVID-19. Okay. At that time, 10.92% of the cases were in children aged 0 to 17. So we'll go again with approximate because these are just the data values they collected, right? They didn't ask me for what data values I wanted. I would have loved to have known the values from about 5 to 18. That'd have been better because those would be our actual kids that go to school. But we'll go with what they've got, 0 to 17, that's fine. So if 10.92% of those cases were children, how many kids did that reflect, right? The kids, the school-going kids. Well, it's 10.92% of the 37,731 cases. And we'll cross multiply again. So this is 100x, and it equals, I'm going to spoil all the fun. This is 412,022.52 is what I have written down. And then if we divide by 100, this represents 4,120 kids. We do need a whole number of kids, so don't tell me you've got a partial number of a child. That's not going to work. Okay, so of the 37,000, about 4,000, give or take, were children. Sound good? Okay. So just because it's 10% of the cases that were children, it doesn't mean that 10% of children got it. Right? It's 10% of something different. It's 10% of the cases were children. So this last question is actually saying, okay, but the number of kids in the state at that point was almost 1 million. It's 981,000. 981,328 kids were in the state of Oklahoma on July 1st, and 4,120 of them had COVID-19. So we're going to figure out what percentage of children had it compared to the percentage of the overall population, right? The overall population number was about 1%. Right? Well, about 1%. So we're going to figure out with kids, was that percentage also 1% or was it something different? So we had 4,120 kids out of the 981,328 kids in the state. And we're figuring out the percentage, x over 100, that represents. So we have 981,328x. And then I have 4120, a couple more zeros on the end. And if we do this division, it should sort of look reasonable. I've got about 400,000 on top, and I've got almost 1,000 on bottom, or 1 million on bottom, right? 400,000 on top, almost 1 million on bottom. So this number should be less than 1 for sure. It's definitely not close to 1% because the top and the bottom are nowhere near close to one another at this point. And if you divide them, and again use 2 decimal places, it's 0.42%. So the general population was at 1%, right, if you counted everybody. And then the population of children that had tested positive at this point was less than 0.5%. So when people would talk about the fact that COVID was affecting one population of people more than the other one, this is what they're talking about. Yes, kids were affected, right? They were definitely affected in terms of catching it or not, but their rate of infection, or at least infection that was detected, like they got tested for it, was half, like less than half of the general population, right? And we shut down schools for this.